Welcome to the General Chemistry 2 class. This section is on acid-base equilibria and salt equilibria. This lesson is about the pH scale. Let's begin. In this lesson, we will define pH. pH, or power of hydrogen, is a measure of hydrogen ion content in an aqueous solution. It is equal to the negative logarithm of hydrogen ion concentration in moles per liter to the base 10. As hydrogen ion concentration increases, the pH decreases. pOH, or power of hydroxide, is a measure of hydroxide ion content in an aqueous solution. It is equal to the negative logarithm of hydroxide ion concentration in moles per liter to the base 10. As hydroxide ion concentration increases, the pOH decreases. Litmus paper is a strip of paper containing certain dyes that change color with pH. An acidic solution turns a blue litmus paper red, while a basic solution turns a red litmus paper blue. Either litmus paper does not change in color when dipped in neutral solutions. The limitation of the litmus paper is that it cannot tell us a measured value of the solution's pH. A pH indicator paper, or simply pH paper, consists of small pieces of paper infused with several dyes that change color depending on the pH of the solution. The variety of colors enables estimation of the actual pH of the solution, unlike the litmus paper, which simply indicates whether the solution is acidic, neutral, or basic. A pH meter is an instrument that allows more accurate pH measurements. It consists of electrodes that measures difference in electric potential or voltage created in the presence of hydrogen ion. This change in potential is related to the pH of the solution. The ion product constant, K, shows the relationship between the concentrations of hydrogen and hydroxide ions. Taking the negative logarithm of both sides of the equation for K gives the relationship between pH and pOH. The equation suggests that at the given temperature, the sum of the pH and pOH of a solution is constant. At 25 degrees Celsius, the sum of the pH and pOH of a solution is equal to 14. At 25 degrees Celsius, a neutral solution has pH and pOH of 7. An acidic solution has a pH below 7 or pOH above 7. A basic solution has a pH above 7 or pOH below 7. Shown are the pH and pOH values of various substances. In the spectrum, battery acid sulfuric acid solution is the most acidic. Gastric juice consists of hydrochloric acid. Lemon has citric acid and vinegar is dilute acetic acid. Tomato fruit contains various acids like malic acid and citric acid. Black coffee consists of certain acid produced during roasting of coffee beans. The acidity of milk is attributed to lactic acid. Blood is quite neutral as its pH is maintained by bicarbonate ion and dissolved carbon dioxide. Seawater is quite basic due to the presence of dissolved bicarbonate and carbonate ions. Baking soda is sodium bicarbonate, which is basic in water. Antacids contains basic substances that neutralize gastric juices. Ammonia is a base. As we learned from our previous lesson, bleach is basic due to hypochlorite ions. Drain cleaners are made up of a base like sodium hydroxide, which helps in breaking down drain clogs like fats and other organic material. To summarize, pH is the negative logarithm of the hydrogen ion concentration. while pOH is the negative logarithm of the hydroxide ion concentration. The sum of the pH and pOH at a given temperature is constant. This quiz is about the pH scale. Let's begin. Number 1. Which of the following statement is correct about the pH scale? Select the correct answer. Number 2. Which of the following statement is the correct about the pOH scale? Select the correct answer. Number 3. Which of the following statement is the correct about the litmus paper? Select the correct answer. Number 4. Determine if the statement is true or false. A pH paper cannot give pH measurements of solution. Number 5. pH measurements using a pH meter is based on the measured difference in electric potential as electrodes are submerged in the solution. Number 6. The product of pH and pOH at a given temperature is constant. Number 7. Select the correct answer. Determine the pH of the following samples. Black coffee. Number 8. Determine the pH of the following samples. Bleach. Number 9. Determine the pH of the following samples. Baking soda. Number 10. Determine the pH of the following samples. Battery acid.